Hello everyone, it's October 22nd. Alright, let's get into it. Power of 4. Give integer return true if it is a power of 4, otherwise return false. Integer power, so without loops or recursion. Power of 4, binary. You want to see what binary look like for power of 4? Binary, what's 4? 4 is 100z, 100, right? That's 4. Yeah, this is a 4. Right. 8. No, power of the next one is 16. 16 is what? Move 2 to the right. Like, so 16 should be this. Is that 16? 0, 1, 2, 3, 4. 2 to the 4. Yeah, this is 16. And 32. No. 64. Right? So 4. So 4 to the third. So 4 to the 1 is 1 left shift 2 times. Right? 4 to the 2 is 1 left shift 2. 1, 2, 3, 4. 2 to the 2, right? 4 to the third is this times 4. We shift 2 more. So 1 left shift 2 to the 3, right? Is it 2 to the 3? Or, no, I think it's 2 times 3. 2 times 2. We left shift 8. Yeah, 2 to the 8. Right? 2 to the 8. So yeah. 4 to the k equal to 2 to the 2k. So it has to have 2k number of zeros. Right? 2k. So the number of zeros must be even. Right? So we can turn the number into binary. Right? We check. Right? We check to see if it's how do we check? Well, we check by or this. No, not or this. We are or exclusive or. Not exclusive or. Oh God, how do I know that the value has all zeros? I mean, I can. If it's all zeros, if we'll AND. Yes, we AND. But how do we know where do we start? It has to be this, right? So it has to be the current value. Current value minus 1. Right? Current value minus 1. Yes. Current value minus 1. And we do an AND. Right? The result shall be 0. If the result is not 0, then yeah, if the result is not 0, then it's not. So that's 1. But we also have to make sure there are even number of zeros. So might as well just get the zeros. Right? Might as well just get the zeros. So we will count. So we'll do this first. Right? Do this first. So do the n and n minus 1. Check if it's equal to 0. Right? If it's equal to 0, then we count how many zeros there are. How do we get the binary from Java? Java get binary of number to binary string. So integer to binary string. What does this return? Binary string. Convert integer value as a string. Do you have an example? Okay, it doesn't have leading zero, so that's fine. So we just do that and count the number of zeros. I mean, if we really do that, why don't we just, yeah, why don't we just go straight for it? Okay, let's just go straight for it. Because we have to count anyway. Yeah, that's not the way. Come on, we have to go IntelliJ. Right? We might as well just do it. I don't have to worry about the other things. Now, what I wonder is if there is any way to not use this. But that is loop, right? Holy crap, that is loop. That is loop. And if you want to do it without loop, we can check this, but this only tells you if it's power of 2, right? We need to know if it's power of 4. How do we know if it's power of 4? Yeah, how do we know if it's power of 4? Plus, it can be negative. Well, if it's negative, it's definitely it'll be false, right? But and a 0 is false. Well, 1 is true. Yeah, 1 is true. But the question, okay, the question I have is, if I don't loop it, how do I know? I mean, I can check this, but this is power of 2. Power of 4. The difference between power of 2 and power of 4 is the number of zeros. I really cannot handle power of without using loop. I mean, I can't just write them all out, right? I can write them out. At the most, it's 1 left shift 20, 1 left shift 30, 32, right? So it's the maximum is 1 left shift 32 minus 1, right? That's the maximum. And I can do 1 left shift 0, right? 2, 4, 6, 8, all the way to 32, right? Now I cannot do 32, 30. We're gonna do 1 left shift 30. So 15 numbers, right? We have 16 numbers. So we can do that. Yeah, I think we can do that. That is not using, so I probably can do set, right, integers. Set goes to new hash set. How do I define hash set? I never remember. Initialize hash set. Array as list. Arrays dot as list. So 1 left shift 2, 1 left shift 4. But you might as well just do yeah, I might as well just do an array. I have to do it 15 times. Yeah, and again, it's the same. It's the same thing. It's the same thing. You have to loop, no matter what. There gotta be a way, right? I don't know. I don't know what other way we can do this. I mean, if we want to do a loop, we might as well just, yeah, I don't know. If n is smaller or equal to 0, right, return false. If n is equal to 1, return true. If n is smaller than or n mod 4 not equal to 0. Otherwise, we return is power n divided by 4. Huh? $16, I got false. What the hell? Does this not integer division? That is bonkers. Even 1 is wrong. Oh, 1 divided by 4. Oh, I'll put this one first. My bad. 1 has to go first. But what else can we do, right? Oh, wait, hold a second. It's always false. It's all right. Yeah. Like what else? 342. This uses recursion. Don't know. What else can we do? If this is a count, right? That's, I mean, in Java you have to like with a loop. You have to loop. Oh, this might be the one. This is the one. Take a binary, so this is the length. Oh, yes. Yes. I forgot I can take the length. But still. Oh, yes, 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 yes. Yes, yes, we can take the length. So, binary version of n, if n is power of 4, must have a leading one and even number of trailing zeros. So with that, we can say string b is equal to integer dot to binary string n. Okay. Then we'll return bin dot length divide mod 2 equal to 1 has to be this, and n minus 1 must equal to 0. Apply to int Boolean operator cannot be applied to int. Oh shoot, here. All right. Yeah. Oh, didn't handle 0. 0. Wait, hold a second. 0. Oh, and we have -1. Oh, and a negative value. If n is smaller or equal to 0, return false. Yeah, that should work. That should work. That is the one. Yeah, you can get a length. You can use a length. Okay, so that'll be it. We're done. Now we need to keep figuring out this one. So where are we? We are trying to write if key is not undefined, I do this. If it's not waiting, and I do this, and I call this .get value again. I set timeout, and I think the first one is correct, but hold on. So the first one. This is the second one. Right? This one's not right. No. The B and C is called too early. Okay, what's the second one? This function, await new promise. So I have to wait for 100. And I call at time 10, I call. The first one is right. Okay? Because key wants to push in, and then it's not waiting initially, and the key length larger than 0, so I do this. I wait. Right? I wait for 100. Once I wait, once I get it, I'll resolve it. And I'll return. Right, we'll wait for it to resolve. Then we call this to return. Yeah, if it's still waiting, so once we've done that, right, so we call this, then we'll be calling this, then we'll be waiting, and then once it's not waiting, and I call this again. Maybe I should put this first. Right? Set waiting to true. Okay, so I'm saying maybe I do this. That is bonkers. How? I call give value. Okay, I got A. Right, I got A coming in. Key is not undefined, so keys.push, get a resolve, get a return, get that, and then not waiting, key larger than this, I do this, waiting set it to true. So right, not waiting is true. And then this is now currently we're waiting for the A, right? And then I call B, right? I call B. Key is not undefined, so this will push B. Key stop push B, and then once it's done, oh shoot! Once I've done this, the keys I have to reset the keys. But if I reset the keys, how am I supposed to? If I reset the keys, yeah, it's because I push into the key again. But the previous one's already executing, so I shall reset the key. But if I reset the key, then when this is done, right, we got a list of results, but which one corresponding to which? So we need a new, every time we call, we need a new one. And we need a new key resolve. We shall copy it. You know what? We shall copy it. I need to have a local key. Local keys. This.keys. I'll copy this. Okay, local keys. Local key resolve. Right, and then I clear the global one. Right, so get the local one, clear the global one, and then this will do everything will be local. Local keys, right? Local keys, and this is local key resolve. This is local keys. Okay, so now this is empty. So when we call B, this one is this key, so it's empty, we have a B, right? But this is waiting, so we don't go through this, right? We don't go through this, so we just return, and then we call C, so we get that, we don't go through this. And then once the A is done, I handle A, then I set this to false, and I call this one again, right? So I will wait for T to call this again. Wait for T. Huh, but this one is also waiting. Yeah, you're waiting 100 for that, and you're waiting another 100 for that, right? And then you call this again. When I call this again, this is false. So this comes in. This is also larger than 0, so you do this. How about this? So we have some local values. This dot key resolve is not iterable. Oh, shoot. I was waiting for too long. And I wait for 300. Huh. That's not right. You wait for too long. Because you're waiting for the query. Right, the query take 100. And then you wait for the 100. So these two shall happen at the same time. But set timeout. So do I call set timeout immediately? Is set timeout blocking? I don't know. Wait, hold on. JavaScript. Set timeout blocking or not blocking? I forgot. You schedule set timeout to execute after a second and then block main thread 3 seconds. Yeah, so it's scheduled. So we shall do this. Right, we shall do this. So once we copy this and then reset, we shall immediately set timeout for the next one. And this will put it into a separate queue for waiting. And now the main queue, I keep doing this. Okay, so this is another iteration. How about this one? This one looks good. Ooh, this one might be possible. Let's see. I think we got this. Definitely not the best one. I am pretty sure of it. But it works. Okay? It works. It works. Okay. Yeah, definitely not the best implementation, but it works. So need to schedule, right? Schedule the timeout before calling query multiple, such that we are not wasting time waiting on both, right? Waiting on both. They can be waited parallel, right? They can be waited in parallel. Okay, let's see. Oh, this one used date.time. Oh, look at this. We return a promise. Maybe we can clear the timeout. It saves in this. This is a better trick. This is a better trick. This is the copy. This is the copy. Okay, so I think I want to do it slightly more. Query function. Query throttled I dot resolve. Key resolve. So how do you want to change? We can say timeout, right? Hold on, we can consider this as the first iteration. Let me try another one. How about we say this is timeout ID? Okay, so it's a null. Okay, we start with null. And key resolve. I like the idea of making it into a this. So every time we get a key, okay, so we say every time key is not undefined, okay, then we say let this will be new. Okay, what do we do is this dot key resolve dot push key resolve. Then we don't have to do any of this, right? If key is not, we do this. Otherwise, we say if is not equal to null, timeout ID is not equal to null, right? And this dot key resolve dot length larger than 0. Don't do this. Don't do this. What we need to do is we do have to do local key resolve. Copy it. Then, yeah, we still have the copy though. Then we can say timeout ID equal to null. This one turning to this again. But hold on, timeout ID. So timeout is equal to null. Okay, if timeout ID is equal to null, right? Then we don't do this. Then this dot timeout ID is equal to this. Then set timeout. And once it's done, timeout ID equals null. But you want to clear timeout, right? Yeah, you know what? Don't worry about timeout ID. I think waiting is fine. Waiting is fine. Okay, waiting is false. What would be a situation where we have a timeout just like dangling, right? That's when you never know, right? You never know. I think that's fine. I'll just go waiting. Right, so this dot waiting. I like to do it this way. So we say set timeout waiting equals false, right? Await of this, it's the keys, right? Keys. And oh yeah, I assign this to it. Then this, that should be fine. And this we can just say local, right? Key resolve dot map, right? Map it dot key. Okay, that's the result. And then we can say for let key of local key resolve. No. No. Here's the result, but the result is in a list. Oh, it's fine. It's fine. Yeah, it's fine. So what we need to do is just let R of let I in res list. There's gonna be I dot resolve. Yeah. Should be something like this. Is that working? Nope. Anyway, I do have to copy it. Ugh. It looks fine to me. Oh, I forgot that this start waiting to set it to true. That's why. Sure. It was still wrong. What the hell? Many error. Yeah. I mean, this is basically the same thing, but we use a better way to handle. But I cannot return this immediately, right? So we have to handle this one. So can we handle this first? Yeah. I mean, I can write one. It's my solution. How do you describe this? I don't even know how to describe this. So this we can say store, right? Store the key resolve in a local value so that we can reset it. Save the resolve in this .key resolve so that we can decide when the returned promise is resolved. Okay, it says get the return values. Yeah, I think that's about it. That's all I want to say. I don't know. I don't have a title for this. I say set timeout. save keys and their corresponding. Save keys and their corresponding resolve in a internal variable. Yeah, let's do it this way. JavaScript. Okay, that'll be it for today. I'll see you guys tomorrow.